We are live.
Perfect. Hello, everyone. Welcome to the demo, to the episode 3 of AEZ Quadratic Round 1. We have three grantees with us today. Um, we have Edward from Pouch, we have Kayansky from CW Orchestrator, and we also have the third presentee, the third grantee, the roll up. They will also be with us very soon. But super happy to kick off the episode 3 of the demo day. Again, we are we're super happy to support the public good funding in the AEZ ecosystem. We are ready to go a step further. We and bring long-term grants and quadratic funding to the Atom Economic Zone, and also the community, give them a chance to sort of put their thoughts forward, vote for the and contribute to the projects that they love. And again, I would like to first of all thank everyone who logged in, everyone who sort of built and submitted their projects to the round. But yeah, I'm also at the same time very stoked to see what these guys have today to present. We can start with Pouch, followed by CW Orchestrator. Fancy, you can go second, and then the roll up folks as and when they join. Edward, I'll pass the stage to you. Feel free to talk about your experience, talk about the product that you've built, and your plans further. Super excited to hear that.
Okay, thank you, Mishka. Let me present my screen. Okay, can everyone see my screen?
Yes.
All right, great. Okay, so I'll begin. So hello, everybody. My name is Edward. I'm from S16 Research Ventures. We are a Web3 fund and validator based in Indonesia. And today we are excited to present Pouch, our submission to the AEZ Quadratic grant. And Pouch is the place to manage and protect your interchain assets. Just before I start, maybe I can give a little background about the project. The original motivation of the project is inheritance. For me, if anything ever bad happens, I'd like my family and my loved ones to be able to access my digital assets. And we believe this is a value proposition that crypto users all around the world can resonate with. So within that context, we define the problem as the ability to inherit digital assets between family members or team members is vital and essential for crypto adoption. Sharing seed phrases does not result this in any meaningful way. So the solution that we have built is Pouch, which is an on-chain fund recovery protocol built on the Cosmos SDK as a complementary security wrapper for existing wallets. And it's implemented as an IBC-enabled app chain. So how it works is a user appoints guardians on the Pouch app chain, and these guardians can initiate a fund recovery process for user accounts on other chains. Security is elevated through the following features. There's a mandatory waiting time before recovery begins. The recovery happens through daily transfers over a period of time, and funds can only be transferred to whitelisted accounts. So if there's any unwanted fund recovery initiation, a user has an opportunity to cancel it. There's also an opportunity here for Pouch since it has the extensibility as an account management platform through its conditional transfers. In summary, Pouch is an IBC-enabled app chain that orchestrates and manages digital assets on other chains. The core value propositions would be that assets are managed from one app chain. The conditional transfer logics reside in one location. Assets stay on their native chain. There's no need to move assets into a Pouch-enabled account, for example. And assets are orchestrated using IBC. So let's get into the product demo. Just before I get into the product demo though, the demo is a little bit more on the technical side. So those who are familiar with the Cosmos SDK tech stack and modules will have an easier time following the demo. So we apologize in advance. We are working on the next demo or the next app version of the application, and we'll abstract away a lot of the complexities. But I think for today's presentation, this should be appropriate. So we'll go ahead here. We've prepared two accounts here. The first account holds the funds, and as you can see, there's two atoms. The second account will be receiving the funds, and currently there are no atoms. So the funds will be received in multiple transfers over a period of time. So we'll go to the current application. This is our project, and you click on this link here in the demo. The app will open. Okay, cool. So let's just start with getting some tokens in the pouch address. Should appear here at any moment now. Great. Okay, so we have one pouch token in the address. So we'll go ahead and create a group, and we'll call it the Fun Recovery Guardians. And we will add ourselves into this group. I've also prepared 2 Guardian accounts, so we'll add those in. Okay, so we have the 3 members here, and they each have a voting weight of 1. We'll go ahead and proceed. The group voting policy here will set as we'll set a 1-minute voting window, as well as the requirement to have 51% of total voting power to proceed and push any proposals forward. Okay, we will sign that. Okay, so the group has been created. Here you can see it's the Fund Recovery Guardians. And if we click on group details, we'll see that the group voting policy as well as the members have been registered. The next step is to connect this to the Cosmos Hub testnet, in which case we will register an interchain account. We will also put in the address that will be receiving the funds, whitelisted, so that we can send the funds over. We'll also do some best practice and put in transfer limits. So in this case, it will be 10 atoms and 10 atoms for the daily limit as well. Okay, we'll add both in and proceed. Okay, everything looks like it's in order. We'll submit it and sign. Great. Okay, so the proposal is ready, and there is a 1-minute voting window here. So I'll go ahead and hurry and vote. Okay. Switch to the Guardian 1 account. Vote yes as well. Transaction has been broadcasted. We'll switch to this Guardian 2 account, and we'll also vote yes. Okay, the transactions, the votes have been complete. I mean, we can review the proposal real quick. So we're going to be registering an interchain account, and these are the validation logics that will be done at the same time. This proposal should be ready for execution. The votes are in. We have 3 yes votes. So I'm just going to go back to the main wallet. Okay, and we can go ahead and execute this. Second, okay, the transaction has been completed. So if we look, the proposal is no longer here. And if we check out the group details, we might have to give it a few seconds, but the interchain account should appear here. Let me refresh it. Okay, great. So the interchain account is registered, and we also have the ISA policies set up. So we have the whitelist address, the transfer limits, and the daily limits. There's one extra step, which is we have to grant the auth. We haven't created the UI UX for this, so we're going to use the Restake app for it. But it works great. So we'll create a new grant here, and we'll give the new interchain account auth grant to send funds. I'll go ahead and sign this. Give it a moment to load up. All right, we can close this app. And that's set up. So the final step is to initiate the fund recovery process. In the technical terms, it would be a recurring transfer in this case. And so we're going to set up this is the interchain account. This is the account that has the funds, where there are currently around 2 atoms. So we will send half an atom. Yep, half an atom. Sorry, I feel like I'm going blind. Okay, half an atom. We'll be sending it to this whitelisted address, and it will be sent every day starting today at 9 p.m., 9:16 p.m. Let's do that. Okay. And it will happen for 4 days. February 4th, 9, 11, 16 p.m. Okay, to give some buffer time for blockchain time. We'll go ahead and submit this. Excuse me. And we will sign it. Okay, again, there's a 1-minute voting window, so let's just hurry and vote. Okay, going to Guardian 1 account. I'm gonna vote yes as well. And finally, the Guardian 2 account. Once it's broadcasted, there we go. Vote yes. Okay, so we have all the votes, and it is almost ready for submission. Just to review, we will be making a transaction on Pouch. We will be sending funds from this account to this account. The transfers will be half an atom, happening for 4 days within this time period. So, okay, we're ready to submit this. Go back to the main wallet. Okay, now we will sign this proposal. All right, and it's through. So if we look at the group details, we should have the fund recovery process scheduled down here, which you can see. It will happen in the next minute, and it is scheduled. So I mean, for the next minute, I think I'll switch over to the presentation to kind of summarize what we did. So what we did was we utilized interchain accounts, interchain queries, IBC callbacks, and OffC to transmit transactions through a designated account on Pouch. This acts as a proxy for the user's primary account on other chains. We built 4 custom modules for this. We have the ICA policy module, which establishes validation logic for whitelists and transfer limits, among others. We have the ICA-TX module, which checks the transactions against the corresponding validation logic. And we have the ICA transfer module, which orchestrates the transfers according to the parameters, such as schedules and limits. Finally, we have an interchain query module, and this query information from the host chains and send it back to Pouch. So we've built all these features. We have recurring transfers, we have transfer limits, we have daily limits, whitelisted address, scheduled transfers, and you put this all together, and we have a more secure, enhanced fund recovery process that utilizes appointed guardians. So we're going to be building more things such as subscription modules, and looking to abstract a lot of these technicalities away, so it just becomes a lot more user-friendly. So I think the transaction should be done by now. Let me just refresh. Okay, it should be through. Let's take a look at this wallet here. Half an atom should be in, and there we go. Half an atom is in. And so over the next 4 days, there will be half an atom being transferred every day until it's completed the 2 atoms that's originally scheduled to be sent. Back to the presentation. So just to reiterate our vision, it is to be the asset management hub for the interchain assets. We believe we've taken the first step forward in this journey. There's still a lot to build. This is what we have to share today. We're really excited to be here and share this with everyone. And if anyone wants to reach out to us to kind of talk, ask questions, collaborate, whatever it may be, do feel free to reach out to us. We'd be happy to have that conversation. And please do support us. We'll need it. And that's what we have today. Thank you very much.
Thanks a lot, Edward. Super amazing. I've seen you build for a while. Super exciting to see what you have it all together. I'm just curious about two things, if you sort of allow me the opportunity to ask you that.
Sure.
Um, in case of, let's say, chain exploits or hacks that happen, can the validation logic sort of be auto triggered in cases like that?
In case there are hacks and stuff. Yeah, that would be interesting. I haven't thought about too much, but logically speaking, then the validation logic would have to be informed that some sort of a hack has happened. In which case, is it automated or is it manual? If it's automated, what are the things to be queried often to know that it has happened? If it's manual, who will kind of, maybe it's like a decentralized manual kind of way to to trigger validation logics. It could be interesting. It could be something to be explored, definitely.
I see. I see. Another thing that I was curious about, actually, what do you think like are the best, some of the best use cases that you see? I know, you said asset management hub at large,
Mm.
but like what are the specific use cases that Pouch can actually nail down?
Yeah, sure. So I think the ones I've mentioned is inheritance, let's say between families. That's one. Things like teams also become a lot easier. People can vote together and make transactions together. You could also create approval processes. For example, certain people in a company or in a team can be allowed to make transactions that are much larger, or certain votes, or whatever it may be, or certain trades in the future, DeFi trades. And then the other team members have access to maybe smaller amounts of trades or smaller amounts of transfers. In this way, you can have layered security depending on what you need. You even have concepts where, like, sometimes you have an investor or you have a board who's not active to the day of the company, but sometimes they need to have an approval in case there's certain transactions that are very, very large. Even these board members, if anything happens to the team, maybe the board members has the ability to kind of like move the funds safely back to where it's supposed to be, whatever the case. So you kind of have more dynamic working relationships between individuals, and we believe this is a first step in that direction.
Interesting. Thanks a lot, Edward.
Yeah, sure. I'll go
Also
ahead.
for
If there's no more
everyone,
questions, I'll go ahead and stop the screen share.
yeah, also for everyone watching, feel free to sort of ask anything that you have in mind. If you want to connect with the grantees who are presenting today, feel free to reach out to them. Again, feel free to also read more about what they've built on the AEZ Quadratic grant page on DoraHacks. um, yeah, for now I think, Edward, we um, yeah, no active questions. Would love to pass it on to Kayansky from CW Orchestrator. Please, Kayansky,
Great,
take
thank
on
you.
the stage and show us what you've built. Thanks a lot,
Yes,
Edward.
hello everyone. Thank you, Edward, for this beautiful presentation. I guess you can hear me okay. Let me share my screen and we'll be good to go. All right, can you see my presentation? Perfect. This
Yes,
is
I
great.
can.
So yeah, let's go. And so welcome everyone. We're presenting today Orchestrator, so CW Orchestrator, which is a scripting, testing, and all-around tool for interacting with CosmWasm contracts. And we'll see later what it means interacting with CosmWasm contracts. So yeah, let's start with a simple introduction inside CosmWasm. So CosmWasm is a smart contract framework which is embedded in almost all Cosmos SDK chains, not the hub yet, but maybe one day, and which is the most adopted smart contracts framework outside EVM. And so if you go on their webpage, it's beautifully detailed, but their main focus is on interoperability and performance, which means having the ability to build smart contracts across all blockchains, having the ability to discuss between blockchains using IBC, using interchain tools, And this is why this is the best smart contract framework outside EVM and even counting EVM, but that's another subject. And to interact with CosmWasm, there are a galaxy of tools that developers have to deal with, and yeah, those tools are so diverse in different languages, in different ways of dealing with smart contracts, that it restrains this galaxy of tools, and no standard way of interacting with CosmWasm means it restricts interoperability between developers with the platform dramatically. And so that's where Orchestrator comes in. So if we want to go to the next slide, so Orchestrator is a tool that solves this issue, that interacts with CosmWasm, which is open source, promotes interoperability, is a Rust library, so we stay inside CosmWasm, inside Rust, and does everything you need with CosmWasm. So that is test CosmWasm script with it, deploy contracts, maintain the contracts, and this is a perfect tool all around CosmWasm. So let's go a bit deeper now in this presentation with a bit more motivation to go inside the details of why CosmWasm is so difficult to deal with today, to interact with, and how we, with Orchestrator, improve this developer experience of CosmWasm. And we'll talk about later at the end of this presentation what other extensions we have brought to Orchestrator that makes it a one go-to tool. So I've been talking for 3 minutes about CosmWasm and interacting with CosmWasm. So actually, when you have a contract, you want to do multiple things with it. So first, you want to be able to interact, push it on chain, uh, develop around it, be able to send messages, queries, etc. So that is the first point. Cosmos SDK nodes. Your application should be able to talk with a node, to talk with the contracts. The second use case is when you want to test. When you want to test your contract, you want to be able to rapidly, inside your own computer, be able to test everything you do to make sure that when your contract is on chain, everything works perfectly and adapts perfectly to the chain you're interacting with. Then you may want to, after deploying, after your contracts are on chain, you want to be able also to debug a specific feature without having to send funds, without having to break your contracts on chain. So you want to be able to, with the on chain state, be able to debug. And finally, you want to be able to have simple command line tools to be able to interact with smart contracts with any chain you want without having to download every possible chain binary to debug things. So those are the four main interactions that we have with CosmWasm, and that as a developer, you want to have one tool to interact with. Because today, for instance, to interact with Cosmos SDK nodes, you may have Cosm JS, so in JavaScript, be able to interact with contracts. You may use CosmRS, so in Rust, with a different syntax, with different things that goes around CosmWasm contracts. If you want to test, then you will be using multi-test, Osmosis Test Tube. These are names that are well known inside the developer world in CosmWasm, and that also bring another syntax, another way of dealing with your contract and duplicate the code you need to interact with your blockchains or your contract. And finally, as I've said, today it's not possible to debug smart contracts easily without having to redeploy everything on a testnet or a test on mainnet, which is really dangerous and costly. And we'll talk about the CLI also in the end. So let's go now on what Orchestrator is and what it brings to a developer. So Orchestrator is a simple unified syntax to do all the things I've discussed before, to do testing, to do deploying, to do scripting, to do maintenance. With this simple syntax you see on the screen, you create your chain, you interact with your contracts. That's it. No other things, no different languages, no different interfaces. With this simple syntax you see here, and I will see in a demo later, you can do anything you need with smart contracts. No other languages needed, no other platforms needed, just Orchestrator, stay in Rust, and do your smart contracts interactions. And so if we want to go a bit more inside the code, we'll see as well that it's really simple to all the types are derived automatically. Your contracts has types, query messages, query responses, execute messages, and different interactions you want to do with it. With Orchestrator, everything has is strictly typed, so there is no don't worry about the types. Rather worry about your application and worry about changes that are propagated. But this is Orchestrator is here to facilitate your life and make sure that also your application doesn't crash, even to scripting, testing, etc. And so with this, we'll jump in a little demo. So that's the next slide. We want to see how to work with Orchestrator and how in actual events it is useful and fast to code with it. So in this demo, very quickly, we will import some contracts and dependencies. So here a token, a fungible token. We're going to write code, which is reusable for every usage we've talked about, test, script, deploying. And we'll see that it's really easy to export your code for others to interact with your code. And so that promotes open source, that promotes interoperability. And this is, I think that it is what blockchain should go towards, and that is open source code and developers working together. So let's go inside the code. Let me show you my window. So on this code window, what you see is so a snippet of orchestrator code. So in this function, we have a token. So CW20 means a fungible token in the Cosmosm. And this token here, we want to upload it, instantiate it, so that means creating the contract. And then finally, we want to transfer it to someone. So this is this to address. So this simple function will create your contract, put it on chain, be it on a test chain or an actual chain, we'll see later, and then transfer the funds to someone. And you see here that we do this code without having, so the chain is a parameter to this function. And what that means is this will run on any environment that you have. So for instance, you have all the environments here. We're going to start with the test environment. And so in this window, we're just going to, let me just do this. We'll simply run this test and see what happens. So this actually just, it's so some here I set up my environment, I call my function, and I assert that everything went well. I sent some funds to my AEZ voter here. So if I just run this, obviously I'm not in the right, all right. If I run this, I see a lot of things happening in the terminal. And so that's what's good with Orchestrator is that you can see what happened. You see that we've uploaded the code, we've instantiated everything, we've had a transfer of so 5,000 here, and we've asserted that everything went well. So that was a simple test to show you that we can do that without spinning out nodes, and we have some nice logs. We have some nice ways of coding things, and that works for tests. Now we can do something else. So it's another test framework here. I'm not going to run it, but it's another test framework that is also integrated with Orchestrator, and that allows you to test on an actual blockchain. So that's called TestTube. Now let's see what happens in an actual node. So here I'm going to interact with local Juno, which is a local Juno chain, and doing almost the same command, which is here. I'm going to run this example, which still uses my function here. And so this as well, it's not right, it's not up, but I can, if I just create my local chain, so this is my local chain here, local Juno, I can do the same code exactly, but this time it is, let me just wait a second. This time it works on an actual blockchain. So you see here, I'm submitting my transaction of uploading my code. So there's too much information here, but we see all the information that is logged with different levels. So you see what's happening in real time, and you can do everything you need to interact with your contract. Here we're just sending some funds around, so that's easy. But this application is composable. So we have, with the orchestrator, we work with Abstract, which is a whole framework, a whole smart contract framework, and we use orchestrator to deploy, to maintain, test, script, debug Abstract, and that's really powerful. So not only in simple cases like what I've just shown you here, but also in huge cases with huge code, it really helps setting up and maintaining all your project. So that was a little code demo that I wanted to show you guys today. And I'm just checking if I have some more time. Yes, I have a little bit of time. Let me just show you a final demo, which is the CLI that we have at Orchestrator. So CLI is a simple way of interacting with smart contracts and Cosmosm on any chain. So today, if you want to interact with Cosmosm using a CLI, you have to download Osmosis D, so the CLI for Osmosis. If you want to interact with Terra, you have this CLI for Terra. If you want to interact with Archway, etc., etc. So we've created a simple tool to facilitate developers' life, interactions with Cosmosm, to facilitate and have things done quickly. And so you can, for instance, go on my Juno local net and see, for instance, my native balance for my address, which I have in another window. Yes, here. Oh, no, that's not the one I want to. I just want to get all my balances for this address, and I can see all the balances I have on this chain. And you see that it's a really simple or CLI, which works with every blockchain, every Cosmosm SDK blockchain, and which will give you the command you just ran, but also have this interactive mode, which works pretty well even for um, starting developers. So that's also good to promote Cosmosm to other developers and bring other developers in our ecosystem. And with that, I'm going to stop here because I think I'm running out of time. But thank you guys for listening.
Thanks a lot, Kayansky. I think this was a super elaborate technical demo. Really a public good to the core, because I think, to get more developers on the Cosmos ecosystem, this would be like a super transformative, exciting tool.
Yes.
Yeah, with that, I don't think I have any questions for you today. But thank you for, again, for building in the AEZ Quadratic funding round. Unfortunately, we do not have roll up team with us today. But yeah, even for them, feel free to sort of go to the hackathon page, go to the QF page, and see what they've built. Um, for everyone watching, would love to actually throw some light on what the judging criteria was. A lot of innovation, originality, the level of public good, how it sort of affects the entire Cosmos ecosystem, what's the practicality of the build that these guys submitted, then the user experience, and potential of future growth, which I think both Pouch and Orchestrator have demonstrated very clearly. Yeah, with that, I think I'd love to wrap up today's session. And this was the final round for the Grantees demo. Thank you for participating, and I wish you all the best for what's coming next for the build.
Thank you, everyone. Bye
Thank
bye.
you.
Yeah,
Thanks for
and again, if anyone wants to reach out to these guys, sort of give any feedback, contribute to the project in some form, feel free to reach out to these folks, Kayansky and Edward. Again, you can see all the details of what they've built if you want to revisit the demo or the GitHub repo on
Oh,
the hackathon page itself.
and I have a final message. So if you like or hate IBC, please talk to us because we have a wonderful IBC tooling that would make you love IBC.
Thanks a
Voilà.
lot, guys. Congratulations.
Bye bye.
Take care.
See you.